Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum. Module 15, Application Layer. In this module, we're looking at the application functionality of the OSI. So we're looking at layers 7, 6, and 5, session, presentation, and application. We're going to end up with talking about some overall structures and services. So we're going to be talking about client server and peer-to-peer networking. We're going to talk about web and email protocols, some basic IP service functionality, DHCP and DNS, and we're going to end it with file sharing. So let's go ahead and jump right on in. Looking at layers 5, 6, and 7, they make up the application layer of the OSI. They also make up the single application layer of the TCP/IP model. The application layer provides basically the interface between the application that we use, the user uses, and the overall functionality of the additional layers, the lower layers, the data flow layers for that communication. OSI, when we're looking at the overall application layer, we're looking at protocols like HTTP, FTP, IMAP, and DNS. Those are all happening at the typical layer 7 portion of the OSI. Again, this is going to be what we, people, interact with. If we're looking at the presentation and session layers, again, these still make up the application layer of both the OSI and the TCP/IP models. The presentation and layer is dealing with the formatting and the presenting of the data at the source device, and it ensures it's in a compatible format. Essentially, this is what's going to be building out the extensions. Is it a .movie? Is it a .jpeg? Is it a .mpg or mpeg? That's what the presentation layer is going to be dealing with. It also deals with the compression data as well as encrypting data for transmission. It also will handle the decrypting of data upon it actually getting it. The session layer is created and maintains a dialogue between source and destination applications for that transmitting of data. It handles the exchange of information to initiate the dialogue, keep them active, and restart if necessary. So it's really important to understand that the presentation deals with formatting, compression, and encryption. The session layer is about being able to maintain the sessions between source and destination. TCP application, again, kind of puts all of them into one giant layer. So when we look at functionality, we have to look at certain things like DNS. DNS is what looks up our domain name services. It takes our domain names and responds them, or actually looks them up to a correlating IP address and vice versa. Google.com will be translated to Google's IP address via DNS. The host configuration is going to be done through DHCP. That stands for Dynamic Host Configuration Protocol. This is what allows us to assign address information. If we're not manually assigning addresses, we have to do it dynamically, and that's done through DHCP. If we're looking at web resources, HTTP or HTTPS, HTTP will use port 80, HTTPS will use port 443. This is the set of rules for exchanging web content, web pages, things of that nature. So let's go ahead and let's talk about some server hierarchy models. Peer-to-peer is one of them. The first one we have to talk about is client-server, though. Client-server has a dedicated server, and you have multiple clients that will connect to that one server. Clients can be anything requesting resources that server serves. In contrast, we have a peer-to-peer network. In peer-to-peer networks, everything is both client and server. Each device will serve whatever resources they have. Each peer can also then request those resources as they're serving the resources that they have. Basically, peer-to-peer applications allow for devices to act as both, and so sometimes these are called hybrid systems. They can both send and receive. They can both be a server and request resources. Common peer-to-peer applications are torrents, for example. I can ask, who has this file? And I can reach out to all of my peers. The people that have those files would then respond. Not all torrents are illegal. Some game platforms, like WoW, World of Warcraft, will actually distribute updates via torrents. That way, they can use everyone in the community that plays World of Warcraft to distribute those updates. That way, not all of the load is on the WoW server for sending out those updates. Moving right along, we have our web and email protocols. These are going to be the protocols used for working on the web and sending emails. So when you go to a website like google.com, www is actually a subdomain, but we don't always see it. But there is actually a protocol or a scheme at the very beginning. HTTP or HTTPS is the protocol or scheme. Then the actual domain, the fully qualified domain name would be like www.cisco.com. www is the subdomain of Cisco. And then the .com actually is an extension. We are requesting a very specific file in this slide. You'll notice the index.html. That is the specific file being requested. So what ends up happening behind the scenes? HTTP or HTTPS will actually use a GET request to retrieve a website. The GET request actually will retrieve the file and then will display it on your web browser. Step 3 is typically the response of the request. The server will send the code for the website. Step 4, our web browser will display that code in our web browser. So HTTP and HTTPS has several common messaging types. 3, just for example, are GET, POST, and PUT. GET is what is used to retrieve web requests. POST, this is basically a upload data file to a web server, such as a data form. PUT basically is upload a web resource or content to the web server, such as an image. So if you're uploading an image, it's using PUT. If you're trying to upload specific types of data, it might use a POST request. If you're retrieving content, it's using a GET request. Again, these are just 3 of the more common types of messages in our HTTP and HTTP requests types. Moving on, let's talk about email protocols. So, we have 2 main types of email protocols, sending and receiving. And it's really funny because people forget that email is not just one-sided, it's both. So if we're looking at what protocol sends email, that's always going to be Simple Mail Transfer Protocol, SMTP. That is the main protocol used to send email. If we're talking receiving email, that actually is either going to be IMAP or POP. And actually more and more IMAP is taking over. And those are used, again, to receive email. So when you go to actually send an email, you will send SMTP using the SMTP ports, and it will go to a mail server. The mail server will then actually have to forward it to the recipient's mail server for them to download it using one of their email services for receiving. Again, IMAP or POP. There are very specific names when we deal with this. Mail transfer agents, delivery agents are also going to be there. Okay, we are not going to talk about mail transfer agents quite yet. So, SMTP uses port 25 to send email. For the receiving of email, if we're using POP, POP is only used to go from the server, the recipient server, to the recipient, the delivery email. That is, in this example, using POP3. POP3 will use TCP port 110. The issue is POP3 is one of the protocols, but when you actually have email on multiple devices, POP will download the email to one device off the server. Well, the problem with that is that's not always the most effective way to deal with this. If you have a phone and a computer, well, only one device will get it. So POP3 has some very limitations in that regard. Basically, in this example, if we're dealing with POP3, the client actually has to pull the POP server, exchange the appropriate commands and responses, and then once they actually receive it, they will get them. Again, POP3, POP, doesn't store messages. It is not recommended for small businesses at all. The appropriate message would be IMAP. IMAP is going to be the main protocol. Here, I know it doesn't quite say mail delivery, mail transfer agent, or whatnot, but these are going to be things that you need to know for the exam. The sender will send an email using SMTP. That will be sent to an email server. That server is going to be also known as a mail transfer agent, MTA. The mail transfer agent will forward the email to the mail delivery agent. And that is going to be the recipient server. The recipient server is then going to deliver the email based off of whatever protocol you have. Again, in this example, we're going to talk about IMAP. IMAP actually keeps a copy of the message on the server. That way, if you have 2, 3, 5 devices, whatever, each device will actually sync between itself and the email server. Thus, if you get an email, it goes to all of the devices. If you read one email, that read receipt will go to the server. The server then will push it out to all the devices that have that same email address. So moving on, let's talk about services for functionality. DNS, DHCP are the big two. DNS is domain name service. Again, it translates a fully qualified domain name, FQDN, like www.cisco.com, and it actually allows us to translate google.com to a IP address. That IP address is then forwarded to the client. The client will use the IP address to route accordingly. Again, routing uses IP addresses. Basic networking deals with IP addresses. We, people, need to know names. That's where DNS comes into play. DNS has several different types of records. The most common types of records are like an A record. That is where we have a domain name and we associate it with a IP address. If we're talking IPv4, it's a single A record. If we're talking IPv6, it's a quad A record. If we're talking a authoritative name server, it will be called a NS record. If we're talking a mail or an exchange record, it will be called a MX record. These are different types of records that are used when dealing with DNS. If we want a specific domain name linked to just a IP address. Again, that's an A record. So you have to kind of understand what the record types are so we know how to query those types of responses. And I said query for a specific reason. Essentially, when we need to ask a question, I need to get to google.com, what is it? The question will be sent to the DNS server. The response should be the answering of, here's the IP address. There should also be an authority, basically a resource record pointing towards an authority. This is what a typical DNS hierarchy looks like. This is what the internet DNS looks like. We have the root level at the very top. Those are all the dots. So like .com actually ends with a dot. .net ends with a dot. All of those belong to the root level. The root level actually then breaks down other top level domains. .gov, .com, .biz, .info, .org. All of those are known as top level domains. Each one then is broken down into second level domains. So if we want to go to google.com, we would actually we'd read it backwards. Dot would take us to the root level. .com will take us to the .com, the top level. Underneath .com, we will go to the Cisco level, or the Google level, whatever we're trying to look up. And then from there, we will go to our subdomains or our third level domains. If we're looking at www.google.com, www is the third level. Google is the second level. .com is the top level. You actually read the websites backwards. That's how DNS looks them up. We also have a computer-based lookup if you want to query DNS to see it from a command line. That's called NSLOOKUP. That's used for Windows-based computers. And we can go to the command line, type in NSLOOKUP, and we can query different domain names and see the correlating responses. And that will be what addresses we're going to be receiving for them. One of the next major features of our infrastructure IP services is how do we get IP addresses to begin with? Two ways: manual configuration or dynamically. Dynamically actually uses what the service called Dynamic Host Configuration Protocol, DHCP. And what DHCP does is it actually leases addresses out of a pool of addresses that an administrator configures. The administrator can configure a pool of 1,000 addresses, 5 addresses, 10 addresses, whatever. The DHCP server can only actually lease addresses out of that configured pool. DHCP for IPv6 is slightly similar, but there are some weird oddities with that. So we're not going to dive too much into IPv6 for DHCP. So how does DHCP actually function? A computer comes online, what happens? Well, there is a very specific operation. The client will send out a DHCP discovery as a broadcast. The DHCP server should respond with a unicast message, and that's called a DHCP offer. The DHCP client will respond with a DHCP request, also as a broadcast. The DHCP server will respond with a unicast address or with the unicast packet, and it's known as a DHCP acknowledgement. The acknowledgement is what actually acknowledges the address that will be utilized. The discovery message basically says, I'm here, I need an address. The offer, which will basically offer a lease to the client, and the client will receive more than one offer due to multiple DHCP servers, so it must choose which one it's going to select, assuming there are multiple DHCP servers on the network. whichever one it actually wants to go with, it will send that as a request. And that message will identify the explicit server and the lease offer that the client is accepting. That is why the server then has to send an acknowledgement verifying that that is what I want. We do actually have a lab looking all of this over. Last actual major service we have to look at is file sharing. One of the big ones is FTP. Basically, what ends up happening is with FTP, it uses ports 20 and 21. It is known as File Transfer Protocol. It will pull data from a server. Step 1, we look through port 21 to connect. Step 2, we establish using port 20, and we can push or pull data based off of that connection. Another file sharing service is SMB, Server Message Block. And this is typically a client-server request-response type method. Basically, we request a file or a resource. The server will respond with an SMB response, and then we provide that functionality. SMB actually is more than just files. It could be other resources. So the three main functions of SMB: start, authenticate, and terminate sessions. That's one. Control file and object resource access, and allow applications to send or receive messages to or from other devices. Those are the three main functions of SMB. FTP quite doesn't reach this level of sophistication. So with FTP, clients establish a long-term connection to the server. After the connection is established, the user of the client can access other resources, not just files. That is the end of this module. In this module, we talked about HTTP, GET requests, POST requests, PUT requests. We talked about email. We talked about web services. We talked about key infrastructure services. We talked about key file sharing services, FTP and SMB. That is it for this chapter. If you have any questions or concerns, please reach out. Thank you.